Hello, this is a video about DelayChecker, a prototype tool developed within the Testomat project. The goal of DelayChecker is to gather information about explicit delays placed in test code, as these may introduce technical debt as well as, depending on the approach used, flakiness in test code. This especially becomes a problem when you consider that these may be part of the regression test suites that are run frequently in a distributed continuous integration environment. DelayChecker gathers data related to delays, which is then exported for further processing depending on the user's needs. It uses static code analysis to classify the type and estimate the duration of delays. The main goal of the classifier is to smoke out sleep-type delays present in the tests, which are flakiness-related test smells. This information can be used to point developers towards improvement possibilities, such as where observability is necessary for a more robust testing process. As the aim was to use it in large code bases, the current prototype uses some heuristics to speed up the classification process, at the cost of some portability, leading to potential false positives. The tool requires some information provided by the developers, for instance the delay signature and its class. The classifier will then analyze the code surrounding the sleep in order to determine the final class. Additionally, the tool also uses some static analysis in order to count the number of potential delay executions, which is then combined with extraction of the durations. For this, the tool requires inputs in the form of how durations are represented, as well as which time units delay functions are using. The output is a delay estimation on the file level. During Testomat, the tool was implemented using the Clang compiler framework and tested against a use case provided by Ericsson. Here, we can see an example command used to run DelayChecker. First, we provide it with a type of analysis, in this case the classifier. Then we provide it with an input file to analyze. If you provide it with a directory, it will automatically run it on all detected test files. We then need to provide it with the configuration tool that DelayChecker needs, such as signatures and timing info of delays. Finally, since I'm using the Clang static analyzer, I need to provide it with the compilation commands that was used to build the files. Here you can see the output from running the script. In this case, it shows the classifications as Clang notes. For convenience, the tool will also output the results to a separate file for further study. Here we can see which file was analyzed. We can see the number of function calls that the tool estimated and which function it was. We can see which time unit was used for the estimation of the delay durations. And we can see the number of sleeps, polls, and weights that it managed to classify in the file. Additionally, the tool can generate and export PDF graphs for fast disseminations to different stakeholders. But for a more interactive user experience, an initial dashboard was implemented using the Dash framework. Here you can see the same results as we saw in the text format in bar plot form. You can interact with the graph, such as filtering out different classes to focus only on the ones you are interested in. For convenience, you can click the bars and it will open the relevant file below so that you can take a look at the context yourself. Let us also look at another alternative if you want to focus on studying the delay context themselves. As the prototype uses Clang Static Analyzer, you can use the open source static analysis infrastructure created and maintained by Ericsson, called CodeChecker. For example, here we see a few of the classification messages given by DelayChecker. And if we select one of them, it will open the code for a convenient way to study the context ourselves. For more information, you should check out the CodeChecker webpage. Future improvements to the tool include reducing false positives in the classification process, as well as using timing estimation to directly propose upper bounds on the delays found. Finally, since the current version should be considered a research prototype, it still needs a lot of front-end improvements to be usable by end users. Thank you for your attention. If you have any questions, please don't hesitate to contact me. You can see my contact information on the screen. Thank you and have a wonderful day.